Okay guys, this is sheet 2 of the rotation solids in contact. Okay, so what we're looking at here is you've got a cylinder and you've got the sphere up against it. So you want to draw it in plane, but the problem is, right, whenever you've got a cylinder with a sphere, what you need to do is really draw it beside it at the same height as at the correct height, we'll say, for the point of contact, and put it beside it and then roll it around it. Okay, that's what we want to do. So what I'm going to do here, so it says locate the sphere in plane and complete the projection. So I want to move that sphere until it's beside. So I'm going to just take the radius, step it out, and that's where the center would be if it was beside it. Now I don't actually need to draw it, but I will just draw it here so people can understand what I'm talking about. So now that is the sphere right beside it, and we know where beside it is in plane, so I can bring it down. That's where the center is when it's exactly beside it in contact. So if it rolls around now, it will stay in contact. So when the center, as it rolls around, it will stay in contact, and I'm going to bring down, and that is the final center. And I'm going to draw this now in its final center. So I'll just set my radius again off this. So that is the final center straight down from here, and this is the point of contact, which I will bring up. POC for point of contact. So if you can always remember that the best way to solve these is draw it at the side. It's the same with cones and spheres. Draw it at the side, bring it down right beside the object that it's touching, and roll it around it if it's a cylinder or a cone. Now, so as I was saying a minute ago there, in this case now we've got a sphere and a cone, but it's the same situation again. I want to draw this sphere. There's my cone. I want to bisect this angle. Draw that sphere beside the cone, bring it down to plane and roll it around. So that's what I want to do. So I know the height is going to be coming across, so I'm going to bisect the angle here, and always do this big rather than small. The bigger you do this, the more accurate. So I'm going to go way out along the cone, I'll go way out along the horizontal, and so there's my angle bisected. So sometimes you see people just doing it down here, 10 or 15 mil, not accurate enough at all. So here's my bisector, so that there is the center. Now I don't actually need to draw this. Now look, you could, if it gives you the one advantage I suppose of drawing it is for peace of mind, you'll know, or you'll notice that there's something wrong, because it should be tipping the cone and it should be tipping the ground, so I won't bother drawing all of it there now, but that is beside the cone. So let's bring it down and let's roll it around. So we're rolling it around. It's still in contact there now. It's rolling up against the spheres, rolling around the cone, and it's straight down from here. So that is our center. So I'm going to just set this radius again. So here is our now the next thing it asks for is it's looking for the point of contact, and again I'm going to go back to where I drew it beside it. So it's 90-degree angle from the side of the cone. So that there is the height of the point of contact when it's beside. So that's not the answer. So I've got to bring that down, and that's the point of contact when the sphere is beside the cone. And I'm going to roll that point of contact around now as well. And it will be on the line joining the center as always. So that there is the point of contact. So now I can project that up. We know the height of it, so I can bring the height of it across. And there's my point of contact. So I brought it down, rolled it around, and then brought it back up. And that is two of them done. Now this is for a hemisphere and a cone. Okay, so it said locate the cone and plan. So again, it's the same, pretty much the same, but we're going to leave the hemisphere where it is. So there's our hemisphere, and we're going to move the cone beside the hemisphere. So here's our ground, so we're going to move it beside it. We're going to draw beside. So I'm going to use the angle here of the pyramid and take that, now take that out parallel, and we know the height stays the same, and if I had wanted to know exactly, I could just get the angle there and go 90 degrees through the center, but that's the right angle, and I know the size of the base of the cone is this. So when I've moved it over, that's still the size of the base, So I now have the cone beside. So now I can bring that down to the top view, to the plane. That would be the center when I bring it down. And I want next now to roll that around. So by rolling it around from the center of the hemisphere, so it stays in contact in when you swing an arc from the middle of the hemisphere. So basically I'm kind of rotating it around the center axis here. So straight down from here. That is my solution. That's what I'm looking for. Oh no, that's off camera, 1 second. Okay, so brought it down, rolled it around, projected it down from here. So there is our center. I'm going to just draw that now. So the base of the cone is this size. Now because the base of the cone goes in underneath, I'm going to just mark this in as dotted underneath it. Now, here is the point of contact when it's beside. So I could bring this down and rotate it around, but I want to show you another way. If I take this across, and I'm going to use a color for this, I think. I'll use green. Now this is what's called a plane distance. In plane, it's going to be that horizontal distance from the center axis of the hemisphere. So I can just take that and mark it. And that's a quick way, if you understand that, of finding the point of contact. Now you'll notice there, look, just to prove it, if I had brought down the point of contact when it's beside, it's here, and if I swung that around, you will find it gives the exact same answer. But you can, if you understand what you're doing, when it's only when it's beside it, it's going to be that far looking down from above. That's the radius. And finally then, I'll project it back up. So there is our point of contact. Okay, so that's 3 done. So our final one here then, we've got a sphere with a smaller sphere rolled in underneath it. And again, the solution is, let's draw beside it. So if I roll that across, the center is going to stay that height. So what I've got to do now is I basically want to add the small radius to the big radius. So adding the small radius to the big radius, and I'm going to swing that around. So that there is the center when it's beside it. Now I don't need to draw it. You can draw it, but you don't need to. And when I bring it down beside it, it is here. Now again, obviously that's not the answer, but when we roll it around it then in contact, so that's rolling it around in contact. And it must be straight down from here. So here is our final our final center. So let's draw that in plan, and just remember now, because it's small, it goes in underneath it. So I'll just mark that light in there. So this is going to be dotted then because that's gone under. Now we want the point of contact. Now the point of contact is always on the line joining the centers. Might actually put this in green. I think it could help people to understand this. I'm going to put the line joining the centers in green. And here was the line joining the centers when it was beside. So there is the height of the point of contact, but I need to bring that height across, and there is the actual point of contact, POC. And it's the same in plan. It's going to be on the line joining the centers. So we know it's here. And there it is. Point of contact. Now another way I could have found it is I could have taken the horizontal distance here when I was beside it. I could have taken that horizontal distance and stepped that out from the center here, and that would have got me the same point also. So show the point of contact as well. Okay, so that is 4 good, very good questions there now on solids in contact.